Alright, 16b, here's I think the last integration by parts video I'm going to do, unless there's specific ones you want me to do after this. I'm not sure if you guys are doing this, but you probably are. So this is where you have to do repeated integration by parts, and then something funky kind of happens. So you can kind of actually go either way here. I typically let u equal the trig function and dv be the exponential function, but it actually works either way as long as you do the same thing for both iterations. So I'm going to let u equal cosine of x, du is negative sine of x, dx, dv is everything left over after the cosine, so e to the x dx, and v is the antiderivative of x, which is e to the x. So then rewriting this, I have the integral of e to the x cosine of x dx equal to uv minus the integral of v du. That's going to be e to the x times negative sine of x. Let's just make it a plus here and a sine of x here. And now for this, we're going to do the same thing. We're going to let, now here's where you have to make sure you make the same choice. If you let u be the trig function here, you have to let u be the trig function here. So u is going to be cosine of x, dv is going to be e to the x dx, du, sorry, u is sine of x, sorry, that's crazy. Du is cosine x dx, and v is e to the x. So now we have the integral of e to the x cosine x dx equal to e to the x cosine x plus the integral of, let's see, plus, sorry, the uv, which is e to the x sine of x, minus the integral of v du, which is e to the x cosine of x dx. And then here's the thing. We ended up with the same integral we're trying to find. So what we do is we add this integral to both sides. So now I've got, well, a thing plus the same thing is 2 of that thing equal to e to the x cosine x plus e to the x sine x. And then finally we divide by 2. So the integral of e to the x cosine x dx equals all of this. Sometimes people factor out the e to the x. I'm not one of those people. Divided by 2, or all times 1/2 plus c. And that's how you find the integral of e to the x times sine or cosine. It also can be done for more terrible versions, like e to the 2x times sine of 3x. So we'll do this one as well. So I'm still going to make the same choice. U is going to be the trig thing. dv is going to be the exponential thing. du, derivative of sine of 3x, is cosine of 3x times 3. v is the antiderivative of e to the 2x, which is e to the 2x over 2. I forgot the dx here, sorry. So this ends up equaling uv. So I'm going to do 1/2 e to the 2x times sine of 3x minus the integral of v du. I'm going to do the e to the 2x times cosine of 3x, but really I should also have a multiple of 3 and a multiple of 1/2, so I should have a 3/2. Don't forget the dx, which I definitely forgot there, sorry. And then I'm going to do this integral using integration by parts. So let's see. Now my u is going to be cosine of 3x. My dv is going to be e to the 2x dx. My du, the derivative of cosine, is negative sine of 3x times 3. My v, the antiderivative of e to the 2x, is e to the 2x over 2. And there should be a dx there, sorry. Alright, so then that's going to go into this integral. So I'm going to get 1/2 e to the 2x sine of 3x minus 3/2 times the integral of this, which is this times this minus the integral of this times this. So it's cosine of 3x times e to the 2x over 2 minus the integral of v du, which is going to be, again, e to the 2x times sine of 3x. I'm leaving off the minus 3/2. So a minus is plus 3 halves. Okay, so now I'm going to write the whole thing out. It's going to be kind of gross. And I do need to write my original integral on the left. So my original integral of e to the 2x sine of 3x dx equals this minus this, and then we have to distribute to that as well. So I've got 1 half e to the 2x sine of 3x minus 3 halves. 3/4. Right, 'cause it's minus 3 halves times all this, which is over 2. E to the 2x times cosine of 3x. And then minus 3 halves times positive 3 halves is minus 9/4 times the integral of e to the 2x sine of 3x. Sine of 3x. Okay, I'm going to add this to both sides. So I'm going to add 9/4 the integral of e to the 2x sine of 3x. Okay, I'm going to get a little bit. So 9/4 of a thing plus 1 of a thing, which is 4/4 of a thing. 4/4 plus 9/4 is 13/4. My integral of e to the 2x sine of 3x equals this. I'm going to leave myself a little bit of room. So that's 1 half. I kind of want to make it 2/4 so I can have a common. Well, you'll see. I'm going to make it 2/4 because you'll see why. So it's going to be 2/4 e to the 2x sine 3x minus 3/4 e to the 2x cosine of 3x. That should have been a 3x, but I lost it there. Sorry. And then I'm going to multiply both sides by 4/13. So I'm going to erase this here. I'm going to multiply it here. I'm going to swap on plus c. And then distributing this through, 4/13 times 2/4 is going to give me, well, the 4's will cancel. We'll get 2/13. And 4/13 times 3/4, the 4's will cancel, and I'll get 3/13. I know that's a little bit abrupt, right? Like you might want to back it up and follow those steps again, but that's how you do problems like those. They're kind of terrible. All right, that's all.